All right. So that's going to be a little bit of a different presentation because we're going to talk about how engineers are working on projects, and this is not technologically advanced as the previous presentations we've seen yesterday. But I think it's all about bridging this gap between engineers and technology, and this is what we're all trying to achieve. So, yeah, I hand over to Kamil, and let's get started.
Okay, hello everyone. So let me introduce you with a short story. So we all, or almost every one of us, started our career path from studying. Very often studying a lot, overnight, just studying for some kind of exam. So we did it just to finish our studies and at the end get prepared to work on that kind of fantastic projects. But even if we work on that kind of fantastic projects, we still have work which needs to be done very often overnight, just before the deadlines. So I'm sure you know that kind of story. We know it too. And that work we do just before the deadline overnight is very often the work which is not so interesting. It's just the work that needs to be done. So we thought a little bit while working overnight, what is the problem? Why do we need to do that that late at night? And the problem we found is communication between disciplines. I mean, weak communication or even sometimes lack of the communication. So I think you already know us. I'm Kamil Grzebalski. This is Agnieszka Tatarczak. We are building digital team in Arup, Poland. And we'll tell you a little bit how we try to manage solving that problem based on two projects that we personally love. So the project I personally love is Optiv, design automation for offshore wind foundations. So let me tell you a little bit what are that kind of projects about. So you could think that it's all about these wind turbines that you can see above the sea level. But the main core of this kind of design are foundations which are underneath the sea level. So these are these huge structures you can see in the bottom pictures. So in that kind of projects, as I think the most of the projects, the communication is mostly about the handshake between the designer and the modelers. So the exchange of information between these two guys is the most often the linear workflow. So if there are any changes in the design, of course there are, because this is the design, there are changes in the project, then the modeler needs to very often delete all of their work or most of their work that they did and rebuild it again and again. So in offshore wind foundations projects, we thought, okay, maybe it could be good just to automate that handshake between these two guys. So we thought that maybe it could be good to change this linear workflow into more circular one. And we work on it. Firstly, we gather all the information from the structural designer and geotechnics designer into one single source of truth, which is one JSON file. Inside this JSON file, we stored the information about the geometry, materials, but also kind of more general information as drawing titles. So having that information inside JSON file, we're able to build automatically 3D models, drawings, and later create PDF files which were ready to be sent to the client with constant track of changes between revisions. So having that kind of workflow, we were able to get information from the JSON file and create element in 3D in Revit one by one using Python coding and Revit API. So to be honest, creation of the elements was the easiest step in this. The hardest one in the geometry processing was creating connections between these elements, because we needed to recognize which element intersects between each others and create nice joints between them, so to create realistic joints. Okay, but at the end, the deliverable for the client are drawings. So having the 3D model and information about the geometry and having the information about drawings inside JSON file, we're able to get this information and create sheets, create views, distribute these views between sheets, and annotate the drawings. So we could add dimensions, add levels, and add tags. So I think the most interesting one are tags, because we created kind of intelligent algorithm that creates the tag in the middle, nearby the middle of the element, and then it checks the intersections between this tag and all other objects in the drawing. And if it finds any intersection, then it rotates a little bit around this center point and checks again the intersections, and again, until it finds the location without any intersections. Okay, and the last step was checking the changes between revisions. So it was basically quite easy script just to compare PDF files between two revisions. So we checked the previous revision and the current revision, and we just compared them in terms of pixels. So we checked pixel by pixel if there are any changes between these drawings, and if there are, we recognize it as design change. And having that information about design change, we're able to come back with that information through Revit and just create a revision cloud around this change. So this is kind of the end of the workflow. So now we can give the drawing like with revision clouds, with all the annotations to the designer, and they can decide whether this is the good product to give to the client or they need any changes. If they need any changes, there is nothing more simple than just give us another data set and we can do the automatic process again. And this is where the circle closes. And that kind of efficient workflow helped us to change our work and to omit that working late. That is the first thing. And also helped us to work on the most interesting things, so coding, in terms of creating more and more tags, thousands of tags, manually. It helped us to make our work more satisfying, make our drawings more accurate, and also we saved budget, which is also very important. And the last addition to this project is another project where we used some part of this workflow, so geometry generation, in the same way. So it is not like we develop workflow and it works only for a project. We can use it and reuse it and reuse it on another projects really quickly.
So the workflow that Kamil was talking about is absolutely beautiful. I mean, smooth data flow across different disciplines is something that we're aiming towards on every single project that we work on. And sometimes we're succeeding, and sometimes, well, we're far off, to be honest. Oh, no. Okay. So on big multidisciplinary projects, there are, the roads team, the architectural team, and the bridges team, and the structural design team. All of them want to work in different software. All of them have their own workflows, and they really do not feel eager to change them for the sake of automation. And this is the example of the project where we've set up ambitious goals to, collaborate with them and convince them towards the automated solutions. So this is Copenhagen Metro project where we're designing the M5 new line, and we're also working on the new Oslik Ringvoll tunnel. This is the road tunnel that will go around Copenhagen. So we're basically designing tunnels, bridges, roads, stations, shafts, ramps, viaducts, everything, a massive project. So we have to be ambitious. So I will show you a couple of examples how we've managed to get ambitious on this project, and that I'm quite proud of. The first thing is the alignment optimization. So instead of drawing manually the tunnel line and deciding how the tunnels in the new metro line will go, we ask the optimization algorithm to set out the tunnels so that we can minimize the total length of the tunnels while respecting all their requirements. So for example, not exceeding the maximum slope or minimum bending radius, or for example, the minimum distance between the tunnels. We're automating an awful lot. So for example, doing some Navisworks C# automation for automated clash reports. So we have these scheduled workflows that every Friday night just go through all the models and automatically export all the data about the clashes between the models. And you know, the project team then can have the well-deserved Friday beers instead of just clicking the export clash report button. We are automating reinforcement, and that required from us sitting down with their experienced reinforcement modelers and asking them, okay, how do you do that? And then changing that into code, into scripts. And of course, there are existing tools that would do that, but from our experience, they're not satisfactory because they never work like our engineers would want them to work like. This is why we're often building custom things inside Arup so that our very experienced Arup engineers are happy with the outcomes. We're automating the drawing production, so something similar to what Kamil was showing, a massive time saver, and hopefully increaser of the overall team satisfaction. And then this is a fun one. We're doing automated quality checks. And we're doing that in a way that there is this very experienced old guy in Arup who used to be drawing reinforcement manually. So we take this guy and ask him, can you check our automated drawings? Can you check them? Can you see whether you spot any errors? And he's coming back and saying, you know, this bar is too long. I think this bar shouldn't be that long. And then we're taking his remark and coding this into automated quality checks. And then after conversations with him, we're building a database of possible errors that he spotted so that the overall quality of documentation is massively increased. And of course, this very experienced old guy, he spotted one error on one drawing. But our automated checks are going through all the models. So then we suddenly discover this error in multiple places. At the beginning we did. And of course, that wouldn't be possible with just manual checking. We're struggling a lot with interoperability. Every team wants to work in their own software, so we had to get familiar with Bentley API and Autodesk APIs. We're coding a lot of C# and Python scripts for all of these so that we can get these models to talk to each other, and we can get this model to be, to form a uniform data set. So for example, this is the open roads automation. We're introducing the same parameters to all these models, no matter what software a team is using. And then we're sitting down with the team, and we're having many discussions, asking them, all right, so how would you input this, structural material parameter? And then they're explaining the workflow, and suddenly we discover that that could be coded. So we code the automated filling in of the parameters. And this is super important. I mean, you could think that it's boring talking about parameters in open roads, but it's far from boring because we can then schedule automated data exports from all of these softwares. So again, every Friday night, we gather all data from all across the project, and then we can use this data to get real data insights. So, as everyone else, probably, we're doing carbon dashboarding, so we're calculating embodied carbon in the structure, and we're doing the same for cost. And I think these tools are super powerful, because very often you're stuck at the meetings where someone's saying, oh, we have to optimize, the stations. We have to optimize the slabs. But when you look at the bigger picture of the whole overall project, you will find out that it's not worth investing in optimizing slabs. We have to focus on tunnels because that's where the real problem lies. So all these dashboards, I really think if people were using them smartly, they would enable us to take decisions, in a way, more data-driven way. And I would love to show you the BIM to cost dashboard, but I can't because this is super confidential. So you'll just have to believe me, that is just absolutely brilliant. So how do we make sure that stakeholders on the project actually look at this data? How do we make sure that somebody opens these dashboards and it's not just us, the digital guys, having fun with Power BI? So there is a platform that we've built for the project, which is called Fuse, and it has all the relevant information for the project in one place. So all the stakeholders, both from the client side, the architect side, the designers, everyone, the project management, they can very quickly access all the information that they're interested in with links to SharePoint, et cetera, with geotechnical information, with utilities data, GIS, GeoBeam, whatever they need. And of course, this platform is built customly for the project. So if someone has specific project needs and they think, oh, this information, it would be super useful for me to have this at hand on this platform, we're just building in another new module to the platform. And then the platform has this project GPT built in. So it's basically ChatGPT, but operating only on project-relevant documents. So then it's super quick to find out what's the relevant information that I'm looking for right now. So for example, what is the tunnel radius? And what's happening in the background in the Python code that you don't see here is that there's an additional prompt asking ChatGPT, please do not hallucinate. Please don't tell rubbish. If you don't know, if you don't find this information in this document, just don't hallucinate and come up with things randomly. And this is super useful. Those are interactive links to SharePoint documents. Anyone can access any information super quickly on the project. And basically, this is it. This is the M5 and Oslik-Ringville tunnel project. We haven't automated the full workflow. We're not as advanced as offshore wind foundations. We haven't created yet the big red button that's going to do everything for us. But I don't think that should be our focus right now. I really think our focus right now is more on talking with disciplines, understanding their specific needs, and really starting this big conversation and explaining that, the circle will be more useful. And this is what we're even more into it right now than just coding. Just talking with engineers and architects and trying to make the digital transformation happen. So thank you, and yes, we'll take any questions.
This was very impressive, and if you may share with us, for us, information, how big is your team of developers?
So currently there's like 6 people in Poland.
Really impressive.
Hi, so Arup is a pretty big company, yeah? How widely have you implemented these automations? Like, how commonly do you use them in projects?
So the offshore wind project, this is used in every project globally that we have. In Hong Kong, in Korea, wherever. If you have an offshore wind foundation project, you're going to use this workflow.
Okay.
So that's a great example. But, the small scripts that I was showing for M5, then it's more difficult to share knowledge and everything because people are used to their own workflows. But when we have something like straightforward and really working, then we can implement it globally on every single project.
Okay, thanks.
Hello, I got a question about this Fuse app, or how do you call it? Because I assume the basis for the data, the single source of truth, is this JSON that you're exporting every Friday for this app. Is that right?
Now, for Fuse, it's really about gathering all the data from many sources. So, so there are the JSON files with the data from the models. There is data from ACC. There is GIS data. There is SharePoint files data. So all across the board, just gathered on one website.
Okay, and you're saying that you're using this for multiple projects then, but is this somehow you can customize which data are being used for the project, or okay, so when you're making this Fuse, you're making different project, let's say offshore platforms need different parameters than, I don't know, Metro, so this whole app is, okay.
So this is my point really, like I'm over the I can do it all tools. I'm over the red buttons. We're really at the stage where we're currently doing custom solutions that can really help a specific project. Because we used to be trying to create universal tools, but then nobody were using them because there was just this one functionality missing.
Okay, that's it, thank you.
Hi, impressive work. I cannot tell you what was the most impressive because everything was as impressive, but about the Fuse, I suppose it's a great revenue stream for your company and clients are paying for it. Okay, that's a good thing. And the tricky question is, how is your IT or IS or somebody from security inviting anyone like the client into the data that is stored on your premise, on their premise, like where's the client getting into? Yeah.
So the place where all the data is stored is just the SharePoint that is set on our side. So this is the project SharePoint that is stored inside Arup, and then all the clients have access to it. And then it's basically, Fuse just inherits all the accesses from SharePoint. So this is our, source of information about accesses. And we're big fans of Power Automate recently for SharePoint accesses. And we're automating the process of managing accesses for different groups of people. And this is really cool.
That's where some companies, I won't name them, but they just don't want anyone from outside of the company into our SharePoint sites. But yeah, maybe I'll use you just an example, like, look, it's possible.
No, but I mean, you can manage the accesses so that they have access to specific folders and they don't to others. It's easy. You know that.
Anyone else? Okay, thank you. Thank you very much.
Thanks a lot.